Welcome back. We're going to keep working with the cars data example, and finally, what we're going to do is incorporate another data source, another variable specifically. So we have the engine size, manufacturer, miles per gallon, but we're going to include another predictor. That's let's say, the weight of the car in thousands of pounds. So we have now the card data example. We have two predictors that are numeric and a predictor that is categorical. Let's take a look at a regression. So, and we're going to do the same thing. Right now, as of last example, we took a look at the levels of the card dataset and specifically of the variable manufacturer, and we still have back the Ford because we rerun the manufacturer variable, and the Ford variable is ordered first. So remember that if we want to change the base, we can use the relevel function, and the relevel setting the reference to the new level that we want. So for instance, if we wanted to change the base level to GM, we would run specifically this line of code. Okay, so taking a look at the structure of the data, we know that this is the variables that we have, but let's go ahead and get the regression. So let's call it regression 4. And I'm going to use the miles per gallon as the response, and the engine size now as a predictor. I'm going to use also the manufacturer as the predictor, as well. And now let's include the weight. So we have a regression that contains actually two numeric predictors and a categorical predictor. So let's look at the summary really quick. All right, so we have now that we get manufacturer GM to have a negative slope or parameter estimate, which means that on average the GM cars have fewer miles per gallon than Ford cars. And that was expected. This not exactly the same parameter estimate than when we had the regression only with engine size and manufacturer GM, because these parameter estimates depend on the variables that are actually included, but it's pretty close. We can see here that the weight is not related. And let me just give you a quick overview on this. Let's do something really quick. I'm going to do a linear model using miles per gallon, and I'm going to get the summary right away. I'm not even going to save it. And the idea is that we want to see if weight on its own is significantly related to miles per gallon. And we can see that it is. By itself, weight is actually a significant predictor of miles per gallon. But when we include it in the regression with the rest of the predictors, it is not. Now, what this means is that whatever information weight brings into the table, it's already included in either engine size or manufacturer or both. So again, the reason for that is if you take a look at the correlation between maybe weight and let's say engine size, it's probably likely that they are correlated. And yes, it's pretty, highly correlated. So that's the reason why you have that case going on. But going back to the qualitative variable, I wanted to show you how when you have two predictors that are numeric, what happens to when you include a qualitative predictor. Before, in this particular graph here, we saw that when we have one predictor that is numeric and the response, when we include a dummy variable, it's like shifting the line. We have two parallel lines, and we are only shifting the y-intercept where the lines cross the y-axis. But what happens? Let's see it now in let's see it in 3 dimensions. We're going to use the car library, and we are also going to use the RGL library. Now remember, many of you were having trouble installing this package, and again, I'm only trying to illustrate what happens. So if you were not able to get it installed, don't worry about it. It's not that that important. So what I'm going to do is I'm going to use the scatter 3D function, and I'm going to put this model right here. The scatter 3D doesn't can't use um, um, variables that are qualitative, but it does have an option. And let me show you first the help so that you see that option in there. It has an option to include multiple graphs depending on a qualitative predictor. And actually, if you look back here under groups, that's the option that would group the graphs according to a qualitative predictor. So that's what we're going to use. We're going to use the scatter 3D function, and we're going to put the model. But we're only going to include this here, and we're going to group according to the manufacturer variable. And we're going to include data set, this is scar data. Now this might actually give an error, and we'll come back to that. Let's see, or probably we'll work it out. It says that the groups variable must be a factor. And actually it is a factor. So this is actually maybe a bug of the scatter 3D. But what I'm going to do is I'm going to go ahead and rerun this. So what I'm going to do is say car data $ manufacturer, and I'm going to force it to be as factor. Again, it is a factor, so I'm not really sure why this creates that particular error, but let's just go ahead and force it. And now let's run it back again and see. Okay. Oops, oh yeah, I see what the problem is. So let's do car data $ this. Let's get it here. Okay. All right, so I'm trying to show that these lines, this regression, is now going to have two planes, and the planes are parallel to each other. But now you have the weight variable, which is a numeric variable, and the engine size, which is also a numeric variable. But as opposed to having just a single line that shifts the y-axis and changes the y-intercept, this is also doing that. So it's only shifting the line up but changing the y-intercept. You can see it right there, as opposed to just with these planes cross the y-axis and right there. So it's just shifting that plane up. So whenever you have a regression that contains a categorical dummy variable, what the dummy variables are doing is just shifting that particular plane or line up or down depending on that parameter estimate. Because the parameter estimate is actually, so if we go up here, it's actually negative. What that means is that the GM, so we can see it back here, the GM actually is situated lower than the Ford because it has on average fewer miles per gallon. So again, this is a demonstration of what happens in 3 dimensions. I hope that that makes says to you. When you have a regression, again, unfortunately, we can't plot anything that has more than more than 3D. So unfortunately, we will not be able to see a graph like this. But at least you have an intuition of what happens um, on the regression by just thinking about it this way. Okay.